Hi everyone, my name is Thomas Kim. Today is July 30th, 2019. This is my 28th episode about graph in C++. In this episode, we will learn how to overcome the limitations of std-beast. std-beast is used to process variant. But this std-beast is not only limited, but also it's very hard to use std-beast correctly. So we will improve std-beast in this episode. Please note that this episode continues from my previous episode, episode 28. If you haven't watched this video, please watch it, because my current session continues from my previous video. If you haven't watched my previous video, you probably cannot follow this episode. Also visit extension talkplayfun.com website and download complete source code. Show in folder, unzip the downloaded file. On the CPP extension graph subfolder, you can find 28beast.cpp, this file. We will continue from our previous episode using file 28beast.cpp. Without further ado, let's get started. Start Visual Studio Code. If you open CPP extension folder, on the graph subfolder, you can find 28beast.cpp. Click this file, right click, copy, then scroll up, select graph folder once again, right click, paste, then right click, rename 29.cpp, hit enter, then close 28beast.cpp. Close this file, Ctrl V. This code is the state of our previous episode. In our previous episode, we defined the class overloaded. We initialize an instance of overloaded using lambdas like this. And each lambda, we define a type, function called operators argument like this. And this type is very sensitive. So in this case, it is reference type. In this case, it is constant reference type. So in the loop visiting each element of container info, we have to specify constant or non-constant. So this kind of programming using std-beast is very easy to make mistake. So this is not good way to program. We will improve this code like this. Here, we will not use Mixin. Instead, I will remove this part. So I remove the Mixin. And I don't need this operator now. Okay? Now instead, I define using visitors T. I define a type. This is std tuple. And the elements are visitor types. So I define the visitor types as std tuple visitors tm visitors. I create an instance of m visitor. Now we initialize this m visitor. Now I have to modify it like this. Okay, this is constructor with this. Now the remainder is the same. Here, please note that we initialize visitor. We can move std move visitors like this. Then we also modify here. So visitor type has a member m visitors. This is tuple. Okay, tuple type. So here, auto reference std get start index visitor m visitors. Okay, we extracted the member from this container, then we call this function, say visit. Okay, then we call like this. We modified like this. So this line of code can be actually the same like this. I will simply copy this part. I copied, pasted, ptr, then return. Okay, so this line of code is the same. Okay, now with this we can simplify like this. We now don't need this kind of stuff. I will simply modify it. It can be auto reference, and it can be also auto, and it can be auto, and we don't need this. Here it can be auto or constant auto, import constant. It can be auto, it doesn't matter. Auto. Now we don't need this. We modified like this. I would say import auto ref. In this case, import constant auto ref. Okay, so with this we can say import auto constant ref, because this is constant, and in this case it can be auto ref. Now we don't need this. So it is much more simplified, because we don't need to concern the type, but we have to concern the order now. The first argument is name. Okay, the second is age, the third is weight. We now have to concern the order. We now have to concern about the order of the lambda functions. Okay, this is name, age, weight. Okay, now we compile it. Start command prompt, G++, std, C++ 17, 29, beast.cpp, hit enter. CLS. Now it works correctly, exactly the same. Okay, now I copy it once again. I pasted it here. Beast simplified. I will copy this function. We can delete this part. Now I will remove this, and I will remove this part too. Now we don't need to concern about this. Now it is auto, info, just info. We fixed like this. It doesn't matter if it is constant or not. So it can be constant or not constant, whatever, it doesn't matter. Also, we can change it to like this. Say, with this, both non-constant case, constant case, both works. Now let's build once again. Now we are calling this function, new function, simplified one. CLS works perfectly. if we want to know the type of each parameter, we can display type like this. String type talk play fun get type category name, and then I will paste it here. It is now age. I will paste it here. It is weight now. Okay, with this we build once again CLS. Now in this case it is integer reference, double reference. In this case this is constant double reference, constant integer reference, because in this case we use the keyword constant. In this case we haven't used the keyword constant. So it is the way we should use std beast. Instead of using std beast, this is the way we should program. We should handle variant type. Another thing is that this kind of code is very typical. So we create a member function here. We create a member function like this. Template, type name, container type, void for each container type, container for auto. I will use DECL type, auto. BT means variant, container. Instead of container, I will use std forward like this. Then here we use types beast. We have to pass this. Then variant BT. Okay, with this we can simplify like this. Instead of doing this, we can modify it, this part. In this function, we can simply do like this. Handle info. Okay, so we can simply modify our program like this. Then we run it once again. CLS, everything works perfect. Now we use the container over vector. Now I will copy it for container over set. Okay, I copied, pasted, paste, simplified, set. Okay, now this container is set. Now it should be in place because the container is modified. So I modified like this. Now the remainder is the same. I will copy this function name, copied it, pasted it here. I will disable it. We build once again CLS. Now the types are all constant integer reference, constant integer reference, constant double reference. Why? So I will compare two cases. Stream, container, vector. I will copy once again. In this case, container is set. Container, vector, container, set. Okay, exactly the same program. We are using, in this case, we are using container vector. In this case, we are using container set. Okay, so If we compare them, CLS, see, in case of we are using container vector, types are double reference, integer reference, double reference, integer reference. In case of set, elements are always constant, because in case of set, we can insert or delete elements of set, but we cannot modify the value of the element of the set. Once again, we can insert or delete elements of the set, but we cannot modify the value of the elements of the set. So the elements values are double, constant, 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 constant. Understanding this point is important. You can insert or delete elements to the set, but you cannot modify the value of the set itself. I will copy this function. Now we will try with the map. Now I modify it into map. Okay? In case of map needs two types. One is key type, one is reference type. Using key T, we will use constant character pointer. Okay? Now we are using map. The type is key type, and another type is variant. So now here we can modify like this. Programmer Thomas Kim. Key type is constant character string, age 30, weight 60.5 kilograms. I will insert another one. Actress Sophie Turner. Her age 20. Her weight 56 kilograms. Okay, this is now map over variant. The value type is variant. Okay, now here we cannot pass the key. Sadly, we cannot pass the key, so it does not work. If we run it, it does not work. Okay, so I will disable it for the time being. Instead, for auto P is pair info, auto key VT P. Okay, P is an element of std map key type T variant T. Okay, P is std pair constant key T variant T. So we extracted the key and variant. Then we can say types beast handle info, then BT. This is the only way. Now we run it. I will copy this function name. I paste it here. I will disable this. Ctrl K, Ctrl C. Now we build. So we passed name, age, weight. But how can it pass? We are calling this type functions, info handle functions. We are passing the value of variant. But how can it pass the key? We can't. In current situation, with this code, we can't. We have to modify this overload function and this beast variant. In my next episode, I will further improve beast variant functions, and I also improve beast to handle map types, container std map, std multimap, std unordered map, std unordered multimap. To handle such map types, I will further improve beast function. Before we close this episode, I will create here, I will copy once again and paste it here and paste it here. Now we are visiting in reverse order. Types, reverse. I simply found this type reverse. Okay? Now I will call this function simplified set. Simplified set. Re-enable it. Rebuild. CLS. Now let's compare this one, this and this one. It beats from name is Thomas Kim and ends weight is 60-50. In this case, weight is 65 and the last one is name is Thomas Kim. So it is reversed. It is in order based, it is reverse order based. Okay? So simply introducing types reverse function, we can visit the container in reverse order. About type reverse, I filmed about it a few sessions ago. So you can search for. So here I implemented reverse range based for. I explained how to implement reverse range based for in this episode. I will copy the link for your reference and also the link. In next episode, we will further improve SED based variant processing or handling function. I will upload complete source code to my website extension talkplayfun.com. By the time you watch this video, you can download complete source code by clicking this link. If you unzip the downloaded file, in the grep folder you can find the complete source code. Please subscribe to my YouTube channel. Thank you for watching.